All right, let's jump right in, shall we? Today's deep dive takes us into the fascinating world of AI, specifically something called attention mechanisms.
Attention mechanisms, yeah.
Now, I know it sounds a bit technical,
It does.
but trust me, this is cool stuff.
It really is.
It's all about how AI figures out which parts of text are the most important to focus on.
Exactly. It's like when we read a mystery novel, right?
Uh-huh.
We automatically zero in on those clues, those little details that help us solve the puzzle.
Yeah, our brains are really good at filtering out the noise and focusing on what matters.
And that's exactly what these AI models are trying to do.
Right. But here's the thing.
Okay.
The traditional methods, using something called softmax attention, they sometimes struggle with word order.
Yeah, it's like trying to put together a puzzle with all the pieces jumbled up.
Exactly. You need some extra help to make sense of it all.
You do. So softmax, it basically allows a probability to each word, indicating its importance.
Okay, like a ranking system.
Yeah, kind of, but it needs these additional clues, these positional embeddings, to figure out the order of the words.
Interesting.
But even with those embeddings, things can get messy, especially when you're dealing with longer pieces of text.
And that's where our star of the show comes in.
All right, let's hear it.
Stick breaking attention.
Stick breaking, huh?
Yeah, I know it's a catchy name, right?
It is.
And the concept is surprisingly simple. Imagine breaking a stick.
Okay, I'm visualizing a stick.
Each break represents how much attention to give to a specific word.
Okay, I'm following.
So as you break the stick, you're essentially allocating your focus.
Interesting. So the size of each piece determines how much attention that word gets.
Exactly. And what's really fascinating is that this method naturally prioritizes the most recent words, much like our brains do.
It does, doesn't it?
Think about it. When you're understanding a sentence, you tend to focus on the last few words to make sense of it all.
It's true. We're constantly integrating new information with what we've already heard.
Right. And the beauty of stick breaking is that it eliminates the need for those complicated positional embeddings.
Ah, so it simplifies the process.
It does, which potentially leads to simpler and more efficient models.
And potentially more accurate too, right?
That's the hope. Now, I know this might sound a bit abstract, but the paper actually dives into the equation behind this.
Oh, there's math involved.
There is, but don't worry, we're not going to get bogged down in the details.
Good, because I'm more of a big picture person.
Me too. The key takeaway is that stick breaking assigns a portion of your focus to each word, making sure you don't miss crucial information.
It's like a spotlight that moves along the text, highlighting the most important parts.
That's a great analogy. And what's really exciting is that this approach has some significant advantages over traditional methods.
Oh, like what?
Well, for one, it allows for a better length generalization, meaning it can handle longer text without getting confused.
That's a big deal.
It is. Imagine reading an entire novel and still remembering details from the first chapter. That's the kind of power we're talking about.
That would be incredible. No more having to reread sections just to refresh your memory.
Exactly. And that's not all. Stick-breaking attention is also less likely to get distracted by irrelevant information further back in the text.
So it's like it has a built-in BS detector.
Yeah, it helps to stay focused on what really matters.
That's really impressive. So we've got this elegant new approach that simplifies things, improves accuracy, and even helps to filter out distractions.
It sounds almost too good to be true, right?
It does. But the real question is, how do they actually put this stick-breaking magic into practice?
Well, that's where things get a bit more technical. But essentially, they had to come up with some clever solutions to implement this idea efficiently, especially when you're dealing with massive amounts of data.
Ah, right. The real world is always messier than the theory.
It is, but the researchers, they're pretty clever folks. They found ways to make this work.
Well, I'm eager to hear more about how they pulled it off.
Me too. And that's exactly what we're going to dive into next.
All right, lead the way. I'm all ears. So, to make this stick-breaking magic happen in the real world, they had to get creative.
Okay, what do they do?
They actually started with an existing technique called flash attention.
Flash attention. I haven't heard of that one.
It's a pretty clever method for handling attention efficiently. Imagine it like a super organized workspace where you only bring in the tools you need at any given moment.
Okay, so instead of laying out all the puzzle pieces at once, flash attention only focuses on the ones you're currently working on.
Exactly. This saves a ton of space and time.
Makes sense. But how does stick breaking fit into all of this?
Well, that's where things get interesting. Stick breaking, with its focus on the most recent information, needs to work backward through the text.
Backward. Why is that?
It's because the stick breaking process assigns attention in reverse order, starting from the most recent word and going back. It's like building a sentence from the end to the beginning.
Oh, I see. So they had to figure out how to make flash attention work in reverse.
Precisely, and that's no easy feat. It's like they had to re-engineer the engine while the car was still running.
That sounds challenging. How did they pull it off?
They came up with a two-phased approach for the backward pass, essentially calculating things in two steps instead of one. A bit complex under the hood, but it allows stick breaking attention to work with the efficiency of flash attention.
Clever. So they've got flash attention working in reverse to accommodate stick breaking. Anything else?
Yes, actually, the paper also mentions something called Triton.
Triton. What's that all about?
It's a specialized tool for writing code that runs on GPUs, those powerful processors that are essential for AI. Think of it like giving stick breaking attention its own custom built toolbox designed to work seamlessly with the hardware.
Got it. So they're optimizing it at every level. But hold on, they didn't stop there, did they? I read something about making it even faster using the stick breaking mechanism itself.
You're right. Remember how stick breaking attention assigns portions of attention until that metaphorical stick is completely broken?
Yeah, like dividing a pie into slices.
Exactly. Well, sometimes that stick gets broken early, meaning all the remaining words can be safely ignored.
So it's like realizing halfway through a puzzle that you already have all the pieces you need for a particular section. You could just skip the rest.
Precisely. They implemented a technique called block skipping, which tells the model to stop calculating attention weights once the stick is broken. This speeds things up significantly, especially for longer texts where many words might end up with zero attention.
That's brilliant. Okay, so we've got this clever idea. They've figured out how to make it work efficiently, and they've even added some turbo boosts for good measure. Now, the million-dollar question, how well does it actually perform?
Well, they put it through a whole battery of tests, and the results are pretty impressive. First, they wanted to see how it handled those long texts that often trip up traditional methods.
So they threw some epic novels at it.
Not quite novels, but they did use a massive dataset called Slim Pajama, which contains billions of words. They trained a model with a short context window, that's the amount of text the model considers at once, and then tested it on much longer chunks.
It's like training for a sprint and then suddenly being asked to run a marathon. Talk about a challenge.
And stick-breaking attention rose to the occasion. It maintained its accuracy remarkably well as the text length increased. Other methods, like the popular rope approach, saw a significant drop in performance.
Wow, so stick breaking attention is like the marathon runner who just keeps going strong. That's impressive. But they also did some testing on a smaller scale, right?
Yes, they wanted to see how stick-breaking attention behaves in different settings. They even designed a task called the multi-query repeated associative recall problem.
Okay, that's a mouthful. Can we just call it the memory match game?
Sure, memory match it is. Imagine a game where the AI has to remember which value was assigned to a variable last, even when the same variable appears multiple times with different values. It's designed to test the model's ability to focus on recency and avoid getting confused by earlier information.
So it's like a test of selective attention, making sure the AI doesn't get bogged down by irrelevant details.
Exactly. And stick-breaking attention outperformed traditional methods in this game, showcasing its ability to prioritize the most recent relevant information.
Okay, I'm seeing a pattern here. Stick breaking is all about focus, efficiency, and clarity. But this is just the tip of the iceberg, right? I'm guessing they didn't stop at testing with a short context window. They must have tried pushing this further.
You're absolutely right. To really assess its potential, they also train some much larger models. We're talking billions of parameters, the building blocks of these AI systems.
Okay, so they've scaled things up, training these massive AI models with billions of parameters. What kind of challenges did they throw at these behemoths?
They really wanted to push the limits of stick-breaking attention, so they used a benchmark called RULER.
Ruler.
Yeah, it stands for Retrieval Understanding and Long-Range Evaluation.
Catchy.
It's designed to test how well models can handle those needle in a haystack situations, where you need to find a tiny bit of information buried in a mountain of words.
Okay, so like being a world-class detective, sifting through tons of clues to find the one that cracks the case.
That's a great analogy. And stick-breaking attention, it really shined in this setting.
Really?
Yeah, it outperformed traditional methods, especially as the text length increased. It seems to have this uncanny ability to stay focused and avoid getting lost, even in a sea of information.
So it's like it has a built-in filter that blocks out all the noise and distractions, allowing it to zero in on what's truly important.
Exactly. And it opens up some exciting possibilities for real-world applications. Imagine feeding an AI a massive legal document or a dense scientific paper and having to instantly extract the key points or answer specific questions without getting bogged down in all the details.
That would be a game changer for so many fields. Lawyers, researchers, students, everyone would benefit from that kind of AI assistant. But they didn't just stop at Ruler, did they? You mentioned they trained even larger models.
You're right. They wanted to see how far they could push the boundaries. They trained models with billions of parameters and evaluated them on a range of challenging benchmarks, including one called MMLU.
MMLU.
Yeah, it stands for Massive Multitask Language Understanding.
Okay, that sounds intense. What exactly does this MMLU benchmark measure?
It's like a comprehensive exam for AI. It tests the model's knowledge across a wide range of topics, from basic math to advanced physics. They really wanted stick-breaking attention could handle a diverse set of intellectual challenges.
So it's not just about memorizing facts or following instructions. It's about demonstrating true understanding and the ability to apply knowledge across different domains.
Precisely. And once again, stick-breaking attention held its own, delivering impressive results and showcasing its ability to adapt and generalize to new and complex tasks.
This is mind-blowing stuff. It really seems like stick-breaking attention is a significant leap forward in AI. But what particularly excites you about this research?
For me, it's the potential to democratize access to knowledge. Imagine a world where anyone can have an AI assistant that can summarize complex information, answer intricate questions, and even generate creative content. That's a future I'm incredibly excited about.
And thanks to this deep dive, we're all a little bit closer to understanding how that future might unfold. We've learned about this new approach to attention, how it works, how it's implemented, and the incredible results it's already achieving.
It's a reminder that sometimes the most elegant solutions are also the most powerful. And it's a testament to the incredible ingenuity and dedication of researchers who are constantly pushing the boundaries of what's possible with AI.
Well said. And for our listeners, remember, even though the technical details might seem daunting, the core idea behind stick-breaking attention is surprisingly intuitive. It's all about focusing on what's truly important and filtering out the noise.
Exactly. And who knows, maybe the next time you're reading a long article or grappling with a complex document, you'll find yourself thinking about stick-breaking attention and how it might be used to make our lives a little bit easier and a lot more informed.
Until next time, keep exploring, keep learning, and keep diving deep